Welcome to PV Online Physics, and today we're going to introduce vectors. Vectors are very important in physics in that they describe many of the quantities we're going to be studying. Vectors are quantities that have both magnitude and direction, and what we mean by that is that not only is the amount going to matter, but which way it's acting. So for example, if you were trying to push a big box out the door, it's going to matter which way you push on the box. So force would be an example of a vector quantity. So the way we represent them is with an arrow, and the arrow is going to be the direction that the vector is going to be acting. Also, the length of the arrow is going to matter. The length of the arrow is going to represent the magnitude. So for example, if you look down here, let's look over here, and you'll see that we have two vectors, both with a magnitude of 5, both going in the same direction, so that if you sum them up, their resultant would be 10. So now this looks like it could be a displacement, it could be a velocity, it could be a force, so there's no unit associated with it. So let's just take a look at it and imagine, if you would, that we were looking at displacement. Remember, we use delta x for displacement, and we use d for distance. Well, as far as the displacement, my displacement, since they're both going in the same direction, it would have been 10, let's make them meters. Now in this case, since they're both in the same direction, the displacement and the distance would be the same. The only difference is typically you would have said 10 meters, let's say east. You would give a direction associated with it. Now in the second example, now we have one where we have two vectors, but they're going in opposite directions. They both have the same magnitude, they're both 5, but they're going in opposite directions. So when we sum them up, it would actually be the 5 minus 5, which gave you the 0. And that would be 0 meters. Now in this case, the distance would still be 10, because I don't care. There's never going to be a negative sign in front of a distance. And so the examples keep going on. And you can see that you had a 5 and a 10 meter vector. And notice how the 10 meter vector is twice as big as the 5. And the resulting 15 meter vector is 3 times as long as the 5. Now the next example, you can see that you have 5 meters going to the right, 10 going to the left. That means the resulting is going to be a negative 5 or 5 meters to the left. Excuse me. Okay, so we can continue on with more and more examples. Notice that whether the arrows point left or right or up or down, it doesn't matter. We still treat them the same. Now let's go ahead and just make a quick little list. I'm going to erase this right here. And let's take a look at a couple different quantities. Let's compare what some of the vector quantities that we're going to be looking at and compare that to scalar quantities. Scalar quantities don't ever have direction associated with them. So some examples of vectors would be velocity, force. When you're pushing something, it's going to matter which way you push it. So force would be an example. Acceleration, whether you're increasing in speed or slowing down or the direction you're going is going to matter. Over here in terms of scalar quantities would be something like time. Time never has a direction associated with it. Speed, we said, was a scalar quantity. How about the number of students in a class? Number of students, it has a magnitude, but it doesn't have a direction associated with it. So you can see the difference between a vector and a scalar quantity. Good luck.